Hello, this video is the second in our series about the concept of nomenclature in chemistry. Nomenclature is of course a fancy word that just means naming stuff. In this video, we're going to learn how to name ionic compounds containing a transition metal and other metals that form more than one charge. Remember in our last video, we asked ourselves the question, does this metal always form an ion with the same charge? We saw that the answer is yes. Naming ionic compounds is fairly straightforward. However, if the answer to this question is no, in the case of transition metals and some of the other metals on the periodic table, we have to do a little bit more work in naming these ionic compounds. The key step in naming compounds that contain a transition metal, or metals that form more than one charged ion, is determining the charge of that metal cation. Now we'll do this by knowing that the metal cation's charge must cancel out the negative charge of the anion in the compound. After we know the charge of the metal, we name the metal in the compound, we will include its charge as a Roman numeral, and then we'll name the anion. We must include the charge as part of the name because the metal won't always have the same charge. We have to include that information so that we're being a little bit more specific about which metal cation is in the compound. Let's start with the example FeO. So Fe is iron, and iron is a transition metal. So I can't predict its charge based on the periodic table. However, I know that oxygen has a -2 charge, and iron must cancel out that -2 charge. So in this case, iron's charge must be +2. So to name this compound, say iron, 2 as a Roman numeral for the charge, and then oxide. Let's look at another example, Fe2O3. So the same idea here, just a little bit more complicated because of the subscripts. So I know oxygen's charge from the periodic table is -2, and since there are 3 oxygens present in the compound, I know that the total charge there must be -6. The 2 irons have to cancel out this -6 charge. Their charge is going to be +6 or a +3 each. So my name is iron, 3 as a Roman numeral for the charge of each iron, oxide. Now it's your turn. Pause the video, name the following compound. The metal in this compound is chromium, which is a transition metal, so I can't use the periodic table to predict its charge. But I do know that phosphite's charge is going to be -3, and I can base chromium's charge off of that. Chromium must be a +3 in this compound, so our name is chromium, 3 as a Roman numeral to designate the charge, phosphide. So what if we have the name of an ionic compound and we want to write the chemical formula? Well, this process is going to look pretty similar to what we saw in the first video. We're going to write the symbol of the cation, and we're going to write its charge. And in this case, we're going to be given the charge as the Roman numeral in the name. Then we're going to write the symbol and the charge of the anion. And then lastly, we're going to balance the charges in our chemical formula using subscripts. Let's use a couple of examples from earlier to see this process. So for iron 2 oxide, I know my metal is iron, Fe, and its charge is specified by the Roman numeral in the name, +2. I know that oxide is oxygen with a -2 charge, and in this case, those charges cancel each other out. My chemical formula is just FeO. In our second example, let's look at iron 3 oxide. So in this case, iron, Fe, has a +3 charge, specified by the Roman numeral. Oxide is oxygen with a -2 charge. Since these charges don't cancel each other out, I need to use subscripts to balance them, and I can still use the crisscross method to do this. So my chemical formula is Fe2O3. Now it's your turn. Pause the video and write the chemical formula for this compound. In this case, copper, or Cu, has a +1 charge, as given by that Roman numeral, and nitride is nitrogen with a -3 charge. So again, we have charges that don't cancel each other out. I'm going to use the crisscross method to get my chemical formula. So my final chemical formula here is Cu3N. If you want more information, check out section 9.2 in your textbook. Watch the other videos in our nomenclature series.